This architecture is for an image processing website. We have tried to distribute the load among two classes of servers, namely website server and backend servers. The website server's sole job would be to handle the incoming page requests for our website. The backend servers will handle any processing that would be needed corresponding to an operation, which in our case could be an image processing. There are two blank entities which are unknown. The first entity will be needed to store the incoming jobs from our website servers. These jobs will be picked up by the backend servers to execute the job. Once a job has been completed, it has to be removed from this entity so that no other server picks it up and processes it again. You might be wondering, why can't we just store this list on the backend servers? This is because we will be needing multiple backend servers for our use case, so this list has to be present on each backend server, and on each successful job completion, all the servers will have to update their lists. Hence, we needed a better solution. Therefore, we came up with a common location which is accessible to all the backend servers, where all our jobs can be stored on a first-come first-served basis. This came to be known as a queue. The second unknown entity is needed to store the processed images. We needed something which can store our images with minimum processing overhead. The obvious answer was a file system for storage. In concluding, we needed queue storage for our first entity, and for our second entity we needed a file system. With an Azure storage account, you can choose from two kinds of storage devices: standard storage, which includes blob, table, queue, and file storage types, and premium storage, Azure VM disks. With a standard storage account, a user gets access to blob storage, table storage, file storage, and queue storage, so let's explore each of these in more detail. Blob storage is basically storage for unstructured data that can include pictures, videos, music files, documents, raw data, and log data, along with their metadata. Blobs are stored in a directory-like structure called a container inside the storage account. If you are familiar with AWS S3, containers work much the same way as S3 buckets. You can store any number of blob files up to a total size of 500 TB, and, like S3, you can also apply security policies. Blob storage can also be used for data or device backup. Blob storage service comes with three types of blobs: block blobs, append blobs, and page blobs. You can use block blobs for documents, image files, and video file storage. Append blobs are similar to block blobs but are more often used for append operations like logging. Page blobs are used for objects meant for frequent read-write operations. Page blobs are therefore used in Azure VMs to store OS and data disks. Azure Table Storage is a service that stores non-relational structured data, also known as NoSQL, providing a key attribute store with a schemaless design. It's easy to adapt your data as the needs of your application evolve. However, this service is now also being offered within Azure Cosmos DB Table API, with multiple more features. Some common uses of table storage include storing terabytes of structured data capable of serving web-scale applications, storing datasets that don't require complex joins, foreign keys, or stored procedures and can be denormalized for fast access, and quickly querying data using a clustered index. There are many advantages of using cloud computing, and of course those advantages also apply to storage accounts. Let's look at how this works with file storage. Most companies will have file shares that are used to store all of the company's assets. Users will upload, delete, synchronize, and do what they need to do to work with the files. Nothing unusual about that. Having on-premises can have some issues though, such as disk space constraints, and you only have a limited amount of storage. Backups need to be configured and maintained, and the security of data can be hard to maintain and requires specialists to enforce. Extending file sharing to other teams, organizations, and entities requires more infrastructure to both supply and manage. All these issues can be resolved though by using a file storage account on Azure due to the cloud benefits that are included. You can share access across multiple machines and can seamlessly connect to your existing infrastructure. It is fully managed, which means that you don't have to worry about hardware and operating system. Azure takes care of it. File storage is super resilient and always available. Network issues or power outages will no longer take out your file storage, such as it can on your on-premises networks, and Azure is always on, as it has redundancies built in. Azure Queue Storage is a service for storing large numbers of messages. You can access messages from anywhere in the world via authenticated calls using HTTP or HTTPS. A queue message can be up to 64 kilobytes in size. A queue may contain millions of messages up to the total capacity limit of a storage account. Queues are commonly used to create a backlog of work to process asynchronously. The concept of data redundancy can help protect against unplanned accidents and failures like hardware failures or zonal outages. From a broad perspective, how data redundancy works is that it creates multiple replicated copies of your data, typically copying your data across multiple disks. When properly configured, if one copy of that disk fails, that data is still readily available because that data is still available on the other replicated disks. From an Azure perspective, Azure Storage will always create multiple copies of your data. This replication process is completely automatic. At minimum, you will always have at least 3 copies of your data depending on your redundancy options, and the process is entirely invisible to the end user. From your perspective, you're only interacting with a single copy of your data in Azure Storage, but behind the scenes, there are actually multiple copies being replicated to multiple locations. What you do have control or interaction with, however, is the different redundancy options that you can choose. In Azure, there are 4 redundancy options available which have different scopes, such as different locations in which you could have redundancy within a single zone, multiple zones in a single region, and it can be replicated across multiple regions as well. The higher availability redundancy options do come with a bit of a higher cost as a trade-off for that higher availability though. Let's take a look at the 4 different redundancy options available within Azure Storage. These redundancy options are roughly broken up into 2 main categories in which you have redundancy options in a single region and redundancy options within multiple regions, specifically 2 paired regions. Within our single region category, we have locally redundant storage or LRS, zone redundant storage or ZRS, and within the multi-region category, we have geo-redundant storage, GRS, and Geo-Zone redundant storage or GZRS for short. Regardless of which redundancy option we choose, all options include at a minimum 3 copies of your data within our primary region, and for our multi-region options, you will also have 3 copies in the secondary region as well. So in other words, you will have either 3 or 6 copies of your data being replicated depending on if we go with one of the single or multi-region redundancy scopes. Let's go ahead and explore each of these in more detail. LRS is our lowest cost redundancy option because it creates 3 copies of your data within a single location, or in other words, within a single data center or a single availability zone. As I mentioned, this is our lowest cost option if cost is a factor, and it is still useful in which it will protect against a single disk failure, specifically these copies that are located on different storage racks in your single data center. So even if an entire server rack becomes unavailable, you still have 2 other server racks safely storing your data. However, since all of our copies are in a single data center or a single zone, this option does not protect against temporary zone or region-wide outages. If this availability zone is unavailable, our data is also unavailable because all copies of our data are within that single availability zone. Well, what do we do then if we want to have a little bit more redundancy or high availability in case of a single zone failure? In that case, we would go up to our next redundancy option, which is Zone Redundant Storage or ZRS for short. Zone Redundant Storage is also hosted in a single region. However, those 3 copies of your data, instead of being hosted in a single location or availability zone, it instead spans 3 different availability zones. In other words, we will have 1 copy of our data in each availability zone within that region. This increases our reliability or high availability in that it will protect against a zone outage, in which if AZ-1 is unavailable, our data is still accessible because AZ-2 and AZ-3 also host our data. However, it does not protect against a region-wide outage because all of our data is replicated within a single zone. So what do we do then if we want to protect against a region-wide outage? Well, we would go up to our next redundancy option known as Geo-Redundant Storage, or GRS for short. With Geo-Redundant Storage, we have 3 copies in 2 different regions. 3 copies will be in our primary region physical location in an LRS or a single zone configuration, and we have an additional 3 copies or 6 total in our secondary or paired region, also in a single LRS configuration within a single data center or availability zone. This increases our reliability in that it helps protect against a primary region failure. In other words, if region 1 becomes unavailable, Azure storage will then fail over to region 2. However, it does not give us zone redundancy in our primary region because, again, we are working within LRS single zone redundancy option in that primary region. One additional feature to be aware of that is unique to our multi-region option is that you also have the optional ability to configure read access from your secondary region for high availability scenarios. This option is enabled by default. You have to explicitly choose to disable this option. However, how it works is that in the event of a primary region failure, the failover process of accessing our data with our secondary region will be relatively much quicker than if we had this option disabled. So at this point, what if we want to have the maximum amount of redundancy possible, even if it does come at a higher cost, in which we want multi-zone redundancy within our primary region and also redundancy within a paired region? In that case, we would go to our highest tier redundancy option of Geo-Zone Redundancy Storage, or GZRS for short. This is, again, the maximum redundancy option. With GZRS, we will again have 3 copies of our data within our primary region. However, it will be in a zone with an option in which each copy is spanned across 3 different availability zones, and we will also have 3 copies in our secondary region as well. However, that is still in an LRS or single zone configuration. This option gives us maximum redundancy in which it can protect against both a primary region failure, which would again fail over to our secondary region, and we can also tolerate a zone failure within our individual region without having to then fail over to our secondary region as well. And like our other multi-region option, we again have the ability to optionally configure read access from our secondary region for high availability, or in other words, to give us fast failover capability. When you're moving data into and out of Azure storage, whether it is from an on-premises location or maybe even another cloud provider, there are a range of solutions available based on either the transfer frequency, whether we are only occasionally moving some data, or we need a continuous automated transfer method. How much data we are transferring, which could range from a few kilobytes to tens of terabytes, and how much network bandwidth we have available for those transfers. This lesson will focus on the objectives for smaller occasional data transfers, specifically 3 different solutions called AZ Copy, Azure Storage Explorer, and Azure File Sync. Let's look into the details of each of these. Overall, AZ Copy is a command line utility for occasional data transfers. Specifically, AZ Copy is a downloaded application which integrates with your command line environment. It is available to transfer both Blob and Azure file storage types. Since it is a command line utility, it is especially useful for automated scripting routines, which can be integrated in both Bash and PowerShell scripts for different automated routines. Next, we have a very different storage transfer utility to focus on called Storage Explorer. Compared to AZ Copy, which is a command line utility, Storage Explorer is a graphical user interface or a GUI interaction method instead. Like AZ Copy, this is a downloaded application. However, unlike AZ Copy, this is a more user-friendly graphical interface which uses an interaction format similar to Windows Explorer to drag and drop different data types into and out of Azure storage. Also, unlike AZ Copy, you can move all storage account formats, not just Blob and Azure file formats, using Storage Explorer as well. Our final occasional transfer method to focus on is that of Azure File Sync. As the name implies, this works specifically with Azure file storage format in which it will automatically synchronize with the Azure file service with on-premises file servers. This is ideal for scenarios in which you have on-premises locations with local file servers. However, you want to maintain the cloud availability of Azure files, in which case Azure File Sync will automatically keep both locations synchronized, giving you the advantage of local file server performance plus the cloud availability of the Azure file service. Common use cases involve disaster recovery scenarios in which you need to back up your local file server up to the cloud. If you have multiple on-premises locations, each with your own local file server, you can automatically synchronize those files between on-premises locations using Azure Files as your primary synchronized source of truth. Other scenarios include some users in the office using a local file server and some remote, in which case your remote users can map their network drives to Azure Files, which will be automatically kept in sync with a local file server as well. In scenarios in which you are slowly but steadily working yourself to a cloud-only implementation, Azure File Sync can serve as a transition step to automatically synchronize both an on-premises file server location and Azure files to help ease yourself into a cloud-only Azure Files implementation as you solely migrate everyone from one location over to the other. In this session, we will focus on two more tools for larger scale data transfer scenarios. Specifically in this lesson, we will cover the services of Azure Data Box and also the Azure Migrate service. Let's talk about these in a bit more detail. The ideal scenario for using the Data Box solution is that in which you have a lot of data that you have to transfer into or out of Azure storage, or you may have limited network bandwidth available to you. Now in this case, lots is a very relative and a subjective term. However, you can easily think of it as a lot of data being simply too much to transfer over the internet. And this is usually relative to the amount of network or internet bandwidth that you have available for those transfers. Regardless of how much that data is, if you have too much to transfer over the internet, Azure Data Box simply provides an offline data transfer method either into or out of Azure storage. As its name implies, it is simply a physical box that is sent to your location, like we see on the right side. DataBox is an encrypted and rugged hard drive in which case for transferring data into Azure. You would simply transfer your data into your Azure Data Box appliance, ship it to Azure, from which case they will then transfer that data from your data box into a pre-created storage account. And this scenario also works in reverse, in which you can take a large amount of data already in a storage account, arrange to have it copied into a data box, and then have it shipped to your on-premises location for an on-site transfer. Some of the typical use case scenario for Azure Data Box include an initial bulk data migration. Maybe we have over 80 terabytes of data in our local data center, which we simply don't want to transfer over the internet. DataBox is ideal for that initial bulk data migration, which can then be followed up with occasional transfers over the internet later on. It can also be used in disaster recovery scenarios in which we have an on-premises disaster that we need to restore from backed up data in our Azure storage location. In the event that it is a large amount of data that we simply cannot quickly transfer over the internet, we can simply restore an Azure site backup to an Azure data box, have it then shipped to our on-premises location for a restore process. And another common scenario is that of security requirements, in which we have data that is deemed too sensitive to transfer over the network, in which case we need to perform an offline data transfer for security requirements instead. Moving on, our final data migration scenario is that of the Azure Migrate service. Azure Migrate lets you plan out and implement a variety of different migration scenarios on moving non-Azure resources into Azure itself. These could be a variety of resources such as servers, databases, and a variety of different applications. One of the more typical Azure Migrate scenarios to be aware of is that of migrating an on-premises data center into the Azure service. This is a suite of tools that perform a wide variety of actions, such as discovering dependent resources to migrate before you even start that migration process, assist in migrating virtual machines from an on-premises data center into Azure virtual machines. It can also help migrate and convert on-premises databases into Azure managed database services, such as Azure SQL, migrate a variety of on-premises application formats, including their discovered dependencies. In Azure Storage, there are 3 premium performance options for applications that have different low latency requirements. Each of these 3 premium performance options operate with solid-state drives as opposed to traditional mechanical hard drives in the background, which are of course much faster by comparison. Keep in mind though, these premium performance options are different considerations compared to the managed premium performance disk types that we talked about earlier in this chapter. Some key considerations that you must keep in mind are, number 1, which storage types are applicable for each premium performance option, and we also need to know the different redundancy options available for each one. All of our premium performance options have less redundancy options compared to a standard storage account, so you are essentially trading more performance for less redundancy. First off, we have our standard storage account option, simply referred to as standard general purpose v2, and this is the default performance option which supports all different types of storage and all redundancy options as well. Again, this is our default performance option when creating a new storage account. And then we have our 3 premium options we will focus on, which are our premium block blobs, premium page blobs, and premium file shares. Let's take a look at these in a bit more detail. Premium block blobs support the blob storage type, specifically blob objects that are stored in blob containers. These are ideal for low latency, high performance workloads which again use blob storage. Typical applications include AI applications and IoT analytics, which use a large number of relatively small object sizes hosted in a blob container that need low latency. From a redundancy perspective, it supports only the single region, locally redundant storage, and zone redundant storage redundancy options. And for that matter, all of these premium storage types only support single region redundancy options across the board. Next up, we have premium page blobs. As the name indicates, premium page blobs support the page blob storage type, or in other words, an unmanaged virtual disk for virtual machines. From a redundancy perspective, it is even more restrictive than our premium block blobs in that it only supports the locally redundant storage or LRS redundancy type, or in other words, it can only support 3 copies in a single zone. Finally, our last premium storage type is that of premium file shares, which again, as the name indicates, supports Azure files as a storage type. This is ideal for high-performance enterprise applications that would typically run off of an on-premise file server. However, in this case, you want to use Azure Files as your high-performance cloud-based file server application. From a file server format perspective, premium file shares support both the server message block or SMB storage type and also network file system or NFS file shares, which essentially break down into Windows file shares for SMB and Linux file shares for NFS. From a redundancy perspective, it is similar to premium block blobs in that it supports LRS and ZRS redundancy options only. Azure Storage provides 3 premium performance options that are available. Premium block blobs support blob storage, which comes with the LRS and ZRS redundancy type. Premium page blobs support page blobs only. Again, think unmanaged infrastructure as a service or virtual machine disks, which supports only the LRS or locally redundant storage redundancy option. And our last option of premium file shares supports high-performance Azure Files applications, which, like block blobs, only support the LRS and ZRS redundancy options.